So here is a cross-sectional view of what we are going to model today. As you can see here, there is a bridge pier, and we are going to model the foundation of the bridge pier. The foundation of the bridge pier is the pile foundation, and we are going to model different strata of soil as clay, sand, weathered rock, soft rock, and hard rock. The pier will be made of concrete, and the different parameters of clay, sand, weathered rock, and soft rock will be defined. Here is a list of different attributes that I am going to define in my model. When we perform the finite element analysis in Midas GTS, we need to define certain attributes. In attributes, we combine the material type and we combine the type of element we want to assign to our finite element. And here you can see a list of different attributes that I am going to provide to my model. You can see that I have a clay type of attribute which has a element type as solid, and I have defined the material properties of clay to it. And this is the list of all the materials that I have defined. It sums up the list of modulus of elasticity, the Poisson's ratio, the unit weight for saturated, the cohesion, and the friction angle. So here is the material list for clay, sand, weathered rock, soft rock, hard rock, concrete, and the concrete for the pile. And we are going to model the pile interface element, and this is the type of pile interface element that I'm going to model. Now I'll take you to GTS itself and we'll see how we can model such a structure in Midas GTS. This is how the work window of Midas GTS looks like. As you can see here on the top we have the menu bar. We can perform certain operations such as creation of geometry. We can create the mesh from here, and we can define certain attributes such as the property as in terms of material attribute. The different boundaries can be assigned. On the left hand side we have a works tree. The works tree would let us know what all work has been done in the model so far. Now as you can see here in the model, I have previously defined the geometry so that we can save time on the webinar. The definition or the creation of the geometry is a very simple process. You need to follow certain steps like creation of a cuboid. Then we can perform certain geometry manipulation features such as translate, extrude, or we can cut certain part of it to create certain geometry. So here as you can see in the works tree, if I go to the geometry, the different geometry that I have defined, you can see that we have 6 different solids that we have defined in this model. If I want to see any solid, I can just check it on. If I want to hide it, I can check it off. So let's check it off all solids and we can activate each solid one by one. So this is the hard rock at the bottom, then we have the soft rock, then we have the weathered rock, sand, clay, and on the top of all of it we have the pier element. I have also defined certain piles as you can see here, and the piles appear inside the curve option. So these are the different piles that I have defined in my model. Now let's see how we can define the material in Midas GTS. The definition of material is very simple. You just have to go to model, property, and material. Now once you go to the material, you can see that I have previously defined certain material types, but let me show you briefly how we can easily define different material types in Midas GTS. Now when I click on add, there are 2 options which pops out. The first is structure, the second is ground. If I want to model the pier or the piles, they come under the structure category, and if I want to model the ground, then it comes under the ground category. So the clay, weathered rock, soft rock will all come under the ground category. In the ground category, as you can see here, you can define several material parameters such as modulus of elasticity, Poisson's ratio, unit weight, the saturated unit weight, the friction angle, etc. And you can define certain constitutive models for the same. So these are the different constitutive models that are available in Midas GTS. and you can select any one of these models to perform analysis. We have provided the Moore column as well as the modified Moore column method for performing the analysis. So let's see what is the different materials that we have defined. As you can see here, I have defined the material for clay, sand, weathered rock, soft rock, hard rock, and concrete. And if I want to see the parameters of each of these material, I double click on it and I can see the different parameters. Now let us define the attributes for performing the meshing on this structure. The attributes will be defined under the property option, and first of all I'll define the attributes for solid. So here I am defining the attribute for clay, sand, weathered rock, soft rock, hard rock, and finally I'm going to define the material for my pier, which is a concrete material. Now after this I'm going to model the attributes for piles, and the pile will be a line type of element. So I'll go to the line type of element and I'll give it a name pile. The element type will be beam, the material will be concrete, and I have to define a property for the pile. The property can be defined in terms of the section, and the pile consists of a 1.5 meter solid round section. So I'll define the diameter of pile as 1.5 meter, and here the section properties are automatically calculated. In this way I have defined the pile element. Now I'm going to define the pile interface element. For defining the pile interface element, I will select the element type as pile and I will define the property for interface. So here I will define the ultimate shear force that the pile can take. Similarly, I will define the shear stiffness modulus and I will define the normal stiffness modulus. And I can also define the reference height and the slope or friction angle or the pile tip spring, but for the sake of simplicity of this webinar I'm going to uncheck all of them, and this is how I have defined the pile interface element. Now after defining all these attributes I am ready to perform the meshing on my structure. Now let's perform the meshing. For performing the meshing I have several options. As you can see on your screens, we have the auto mesh option, or we can do the map mesh, which is the structured meshing. Now I'm using the auto mesh option and I'll be meshing the solids one by one. So first of all let's mesh the pier element. For that I will select the solid as pier solid. I will define the mesh size. I will define the attributes for pier. And I can see the preview of how the meshing will look like, and once I click OK, the meshing has been performed. Similarly, I will perform the meshing for all other solids. So first of all I am performing the meshing for clay. I will select the solid as clay solid. I will give it a name clay. Now I'll perform the meshing on the sand, and I will select the solid as the sand solid. Similarly, I will perform the weathered rock meshing. And now I will perform the meshing on soft rock. and hard rock. So in this way you can see that the meshing of the structure has been completed. And here in the mesh set, in the works menu, we can see how many meshes have been defined. So here you can see that this is the pier mesh, the clay mesh, the sand mesh, the weathered rock, soft rock mesh, and the hard rock mesh. So in this way we have performed the meshing on this model. Now let's perform the meshing on the pile elements. For meshing the pile elements, I will go to the auto mesh option for edge. And I will define the number of divisions as 1. I will select all the piles, and in this way the pile has been meshed. Since I said that I'm going to define a shear curve for performing the analysis on the pile, the shear curve can be defined under the property option for pile interface. So here I can define the function for shear curve. When I click on this, I can define the parameters for the shear function. So let us define the parameter for the shear function. So here I am defining the parameters for the shear curve. So in this manner, as you can see here, I have defined the shear curve. This is a representative shear curve. We can define the shear curve in any manner we want. I am selecting the direction as Z. So now I have selected the shear curve, and once I click OK, the shear curve is assigned to the pile interface element. Now I will be creating the element for the piles. For that I will go to the model, element, create pile element. When I select this element, I can select all the pile elements and I can assign them the pile interface element. So here, as you can see, the piles have been created and the shear curve has been assigned to the piles. Now I will define the supports to this model. For defining the supports, I will first define the boundary supports, which is the ground support. So I will give it a name, ground support, and I will select the mesh. Since the ground support will be provided only to the clay, sand, weathered rock, soft rock, and hard rock, I will select only these mesh sets, and once I click OK, the support has been provided to all these 5 mesh sets. Now I will provide the support to the pile element. For that, I will uncheck all the mesh and I will check on only the pile mesh, and I'll go to model, boundary, supports, and I will restrain the torsion in the piles. So I will restrain the RZ and I will select all the nodes of the file, and when I click on apply, I have restrained the torsion in the files. Now I will define the self weight. For defining the self weight, I will go to the load option. In the self weight, I can define that the self weight is in the direction of gravity, and I will give it a factor of 1. After this, we can model the analysis case. For modeling the analysis case, we have to go to analysis case. We can give it a name, let's say bridge pier, and we can select what type of analysis do we want to perform. Here you can see that I am selecting the nonlinear static analysis, and I am putting all my mesh set into the activated field, the ground support into the activated field, and the self weight into the activated field. And once I click OK, the analysis case is set up and I'm ready to perform the analysis. So this is how the modeling is being done in Midas GTS, and now we have finished the modeling and we can perform the analysis. I won't perform the analysis, I will just open a previously solved model and I will show you the results on this model. So here I have defined all the parameters that I have shown you in the webinar, and in the post processing you can see that this model has been analyzed. So let us see the analysis results for this model. So first of all, let's obtain the displacement of this model. So here you can see that this is the displacement profile for this model. If you want to obtain the displacement at any position, you can obtain the displacement. You can check on the mesh edge, and if you want to obtain, let's say I want to obtain the deformation at this node, then I can select this node and I can obtain the deformation. Similarly, I can obtain the deformation at any node I want. So here you can see that Midas GTS has put up some tags and they determine the deformation at that location. Similarly, I can see the deformation in YZ, in the Z direction, etc. Now let us see the 3D element stresses in this model. So here let's see the stresses in the global YY direction. So this is how the stresses look like. If I want to obtain the stresses inside the structure, then I can go to the slice plane option and I can select the plane where I want to obtain the stresses. So let me switch off the mesh edge so that we can see it clearly. How does the stress look like? And here you can see that we can move the slice plane anywhere and we can obtain the stresses inside the structure at any location where we want. So this is how you can obtain the results in Midas GTS inside the structure. We can also obtain the strains. So here, as you can see here, we can obtain the strain. So let us obtain the strain in the direction of gravity, and here you can see how does the strain look like. Let me switch off the slice plane option, and here you can see this is the strain profile for this type of analysis. Now let us obtain the forces in the piles. For obtaining the forces in the file, I will go to the 1D element forces option, and let's see the forces, the bending moment in the major axis for the piles. Now for that I will check off all other mesh sets and I will go to and I will check on the mesh set for the piles, and here you can see that only piles appear in the result and we can see the results for the pile. So if I want to obtain the bending moment, this is how the bending moment profile looks like, and I can obtain the force in the direction of gravity for the piles, the shear force in the Y and Z direction, and I can obtain the torsion force, the bending moment, etc. Similarly, I can obtain the 1D strains. So here this is how the strain looks like. If I want to obtain, so this is how I can obtain various results in Midas GTS, and this is how you can perform the analysis for a bridge pier using the shear curve. Now if I want to obtain the pile tip displacement, then I can go to the option, the pile element, and here we can see the total slip displacement in the X direction. the opening displacement in the y direction, the opening displacement in the local z, the plastic slip displacement, shear force along the interface x, and the normal force in local y and z. So here you can see that you can obtain a variety of results from GTS, and this is how you can perform the analysis for the bridge pier in Midas GTS. Now let us take the questions. If you guys have any questions, then let me know through the chat window. So I've got one question. From Mr. Singros. He wants to ask, could you elaborate on the shear curve? What are the units? What does it mean? And what kind of testing do you need to obtain the curve? So here, let me first tell you what kind of units have I used for defining the shear curve. As you can see on your screens, you can set up the units here. So I have used the units as ton force meter. And if I go to model, property, so let us see the shear curve. So this is how, sorry,